TEAS. We're a little more cramped than usual, but it also looks like we are a little lighter than usual in terms of number of people, so it's going to all work out. Blue sheets are going around as usual. Please sign. And as I mentioned before, we have a Etherpad link on the bottom of the slide here. Please join it and help us capture minutes of what goes on. Usually we don't take notes on what people are presenting, but more of the conversation. We have a new note well. I feel like I'm really loud. Okay. We have a new note well. For those who have been here for a while, it aims to more clearly state what I think most people already know. Basically, whatever you say in a session becomes part of our public record. Please familiarize yourself with the note well and the related documents. We are doing our usual audio and video streaming. When you make comments at the mic, once it shows up, please make sure to state your name for the record. I am on Jabber. Right now we don't have anyone on it, but I will be trying to watch the Jabber room to make sure that if anyone wants to add anything remotely, we get that read into the mic and the questions responded to. Nothing has changed with chairs and secretary. We appreciate Matt's help. Even though he continues to be remote, he continues to be very helpful in helping us put together agenda, get the slides posted, and capture minutes. Where do we stand on documents? We have one new RFC. Thank you to those, oh, sorry, two new RFCs. Thank you to those who contributed to the work. Very much appreciate that and appreciate seeing that we are actually getting documents out. We have two more documents in the editor queue, and notably, we have quite a number of documents that are in publication request, including one that went in yesterday. We had been working on that TE topology for quite a while, and there was one section that needed a little cleanup. It took us a little bit to get there, but that got there last month, and now that's in publication request. So that represents a fair bit of work. So we look forward to new RFCs, hopefully before the next IETF on all those publication requested documents. We have one document that's post last call. There's a little bit of cleanup that's being discussed between the document authors and Shepherds. It's not expected to be a significant change, but it's still something we want to see cleaned up before we submit to the ISG for publication. We have a few new working group documents. Some of them are in the agenda, some are not, but that represents good continuing new work for the group. It's important to, if you haven't read those documents, please read the new documents and comment on them. Excuse me. We have one document which is a little bit coming to the group a little bit differently than most documents. This is the RMR document. This document was headed towards the adoption in the MPLS working group, and through some discussion with the chairs and AD, we agreed that it actually belongs not in MPLS, but in TEAS. So we expect this document to come in and be adopted. But of course, we will do our normal adoption poll, but I think it's just surprising to see a poll without having it discussed before, and that's because it has been discussed before, it just is moving into this working group. Do we have a question? We have an MPLS working group chair coming up. Mike.
I don't think you should overestimate the amount of discussion we had on that document in MPLS. Actually, the only thing we discussed was where it belongs. So we haven't discussed it technically, really. Same goes for the LDP one. So, about to start that.
So are you suggesting that we have more discussion here before doing adoption?
I would at least allow for it. You should pull the list and see if there are reviews. I reviewed the document halfway through before we actually decided this is TEAS, and I sent those comments to the authors. But that's all the review the document has so far.
Okay. So, it didn't go through your normal review team? I thought it went through the normal.
No. We were about to start that process when we actually decided, okay, we need to check where this document belongs. And that discussion ended up moving to TEAS, so we haven't really done any review.
All right, then we'll talk about that offline, and then come back to the working group on the list and suggest how to proceed.
Okay, thank you.
Thanks for the clarification. We have one incoming liaison. This is a typical liaison we've received from ITUT over the years. It's very good to see the synchronization of activities to make sure we have a common understanding across the different working groups. This actually came into not only TEAS, it came into, I think, CCAMP. Sorry. Came into CCAMP, MPLS. Did it also go to PCE? Okay. In the past, CCAMP has taken the lead on responding to ITUT, this type of liaison. We haven't talked to the chairs if they want to take the lead. It doesn't necessarily require such a formal response, but we were thinking we'd proceed the same way. I'm seeing a CCAMP co-chair nodding his head, so we'll proceed as we normally do with these liaisons. In general, please feel free to send comments to the TEAS working group, and in this case on the liaison also please CC CCAMP. And thank you to whoever fixed the mic. As a reminder, we have an IPR process that we follow, which includes polling both before adoption and last call. Please follow our process. This is part of what's captured in that note well. If you need references on this, go look at the note well slide or the note well page off the IETF top page. As always, we really appreciate the discussions being brought on the list. This is even including authors. I think we've seen a good example of that with the work that's been going on with Yang and TE Topology, where there's a lot of meetings that are happening and the reports are sent to the list. That's a very good way to keep the working group aware of what's going on and provide the opportunity for those who wish to contribute, who may not be authors. It allows them to contribute to that work and the consensus building process. So that's really important. Please use the list. And as always, we try to allocate time based on list discussion. So if you want more time in this session, have more list discussion. And with that, we're going to move on to the next slide.
Good morning, everyone. We'll now quickly look at the status of the working group documents. We currently have 23 working group documents. There are 11 that are in various stages of the publication process. 6 are on the agenda today, so that leaves us with 6, and those are listed up here. The first couple of documents listed here were adopted last month. There hasn't been any progress on these since adoption, so we'll skip those. Jump to the one that's listed third. That's the PCECC use cases document. We did not receive any status for this. There hasn't been any change to the document since April of last year. This is currently an expired document, and based on a prior update, there was an indication of intent to make further changes to the document. We haven't seen that happen. Is there anybody representing the authors who would like to come out of the mic and give an update on this?
Mr. Yogi, Malik. So as you list the document will be updated after the meeting, after the discussion, between all the meetings, will publish the update.
Okay, thank you. Next is the T metric recording document. The authors were kind enough to send a status update late last night. There haven't been any changes to the document since November when it was revived and brought back from the dead. There are still some outstanding comments on the list that need to be addressed. And in the previous update, the authors did say that they would like to align the procedures in this document with the ones that are specified in RFC 8001. So I'd like to see those two items get addressed before we have any discussion on moving this to the next step. Is there anything that the authors would like to add to this, since it came in just last night? I don't see anybody coming up to the mic, so let's move on. Next is the L3T topology Yang model. This was adopted last month. There was a revision published for this early this month. The changes were primarily done to address some warnings from the Yanglin tool. There's still some work that needs to get done before the authors can say that they are ready for the next step. In the meantime, they're requesting the working group to review the model and reach out to them if there are any specific concerns. Next is the SRT topology model. The update for this is quite identical with the one that we saw in the previous slide. There's still some work that needs to get done before this can progress to the next step. In the meantime, it would be good if you could get some thorough reviews in for this model. That's all we have in this slide deck. Next is an update on the T and RSVP modeling efforts. That would be given by Tarek. Yeah,
They will.
in a minute.
Don't rely on my memory. Yeah. So good morning, everyone. It's good to see you all again. Hope you had a nice day. My name is Tarek Sat, and I am presenting a. Can you hear me well on the mic?
Tap it. Is it working? No, is the mic working?
No.
Switch.
Oh, no, it's the switch on.
It was working. It maybe the battery.
It's on. Then. Now it's working. Well, okay, try number 2. Does it work?
No.
Okay. Try number 3. Is it working? Can you hear me well? Okay. So this is a short update on the working group drafts, the 3 of them I'm listing here. I'm up for a big slot. I don't think I'll take all of it, so I'll try to give back some of the time for other slots in case we needed it. I am presenting on behalf of the co-authors here. An overview of my slide deck. I'll go over the updates. I'll talk about the open issues and close off with next steps. Before I go to the updates, a little bit of document organization. We have, at the moment, 3 documents, as I was presenting on the first slide. The first document, in terms of organization of the modules, it covers the RSVP, the data modeling for RSVP protocol, and an extended module for that, base and extended. So that this has been driven in one document, separate document. The second one is basically an augmentation of traffic engineering for the RSVP protocol, and it contains or seats 2 modules. the RGP and the MPLS data plane instantiation of it, and that's being driven in a separate document. And the third document that we have, the TE, Yang TE at the moment, it is seeding multiple modules, including the generic TE data plane agnostic modules. I have them highlighted in green here. Basically, the TE tunnels module, data plane agnostic, and the device specific attribute, and the TE types module for reusable groupings and so on. And then there's the MPLS specific modules, the TE MPLS, TE-SR MPLS, and TE types MPLS. They're all seated in one document at the moment. We've got some advice to split it up into two documents, one containing the data plane agnostic part, and the other is MPLS part. So that's an action item on us. We are planning to do this in the next update before we push for the working group last fall. And obviously, we will try to split it into two parts, one the MPLS and the other one is the data plane. So this was about the organization of the documents. I'll move on to the updates on the first version that we're driving. In terms of summary, I have to start by thanking all the team that is continuously meeting and driving this work to completion. I'm not mentioning anybody in specific, but thanks to all. In terms of the changes, we've added RFC references in many places in our models. So that was one big update that we had. We have several updates in the TE tunnel model. I'll go over that. And lastly, I have some editorial updates to the RGP and RGP TE models.
Tarek, thank you for just going back to the previous slide. Thank you for those updates. They're really good, and it's nice to see those references. There's still some, I took a quick look through and definitely noticed a big change, but there's still places where there's an element that's being configured that doesn't refer back to the base spec, whether you're talking about 2205 or 3209 or whatever. And I think it's important on those in particular to note what the right reference is for those. So it definitely is a big step forward, but there's still pieces that don't refer to the default, the base. And as long as it's not sort of the base, I think we have to have a reference there.
Sure.
And in some places, I know there's not good references. And in that, let's just make sure to have a good description.
Exactly. Thanks for that comment there. We have to take that as an action item on our side, and I'm committed to address it.
Yeah, it's good. It's just that sometimes there's pieces there that we all know because it's in all implementations, but for someone new, if they don't have the reference, they have to know what to do with it, and we just want to be clear there.
Makes sense.
All right, thank
Definitely.
you.
Okay, moving on to the first update in the model. We have an explicit route list where we specify the hops. We noticed that we needed a hint when the path computation element or the engine is trying to expand a loose path. We wanna like a hint to indicate that it should stop on a link as incoming. So the computation will enter the node specified by the hop, or it should exit in the outgoing case. The computation will exit the node at the specified hop. Currently, this is not even in the explicit route object or sub-object that we have in RZP. There's no indication to say that this is the computation should stop on incoming or the exit or the egress of the node. So we thought in the modeling we needed this hint, and we added this direction for the numbered hop case as well as the unnumbered hop case. The second update to the same explicit route list that we have in the model was for the label, and we added a label direction. So in the list, we have an option where we can add a label on a specific link And what we wanted to indicate that this label is an upstream or downstream assigned label. So for the forward direction or for the reverse direction. Again, this applies to the label top in our explicit route list. The third update, we added for protection and restoration several actions that can be invoked on a specific tunnel. Actions like freeze. So basically, if you have a working and a protection path, you don't, by freezing, you ignore basically switching from from working to protecting. You basically don't act on any action invoked by the user once you freeze it. And then the second action is a clear freeze, which does the negative of freeze. It resets it. Action lockout of normal. Basically, it locks out normal traffic from using the protection path. And then clearing of lockout of normal. The next action would be lockout of protection, which disallows extra traffic and normal traffic from using the protection resource or protection path. And we have an action force switch, which forces switch over from the working to the protection path, regardless of the state of the protection path. So basically, no additional checks for the validity of the protection path are done. So the description, we try to make it as much descriptive on its own. Hopefully, please do go through the description. If it's not clear or ambiguous, let us know, and we'll try to update it. And the next one is a manual switch. So the difference between a force switch and a manual switch is there are some additional, in the manual switch case, additional checks for validation are expected from the device. And yeah, the action exercise is specific for ATS. Description is in there. So please do go through the actions. The references are there. They're being inherited from the IT documentation. And there's RTF as well. So we defined the actions. Now we are defining the RPC itself in the model on a specific tunnel. The RPC will take input, the action that we just went through on the previous slide. It will take a location where the action is being invoked. Is it on the ingress, egress, or even on both? So there is a node ID where you can specify where the action is expected to be invoked. And there's a path reference. So in case you want to switch over to a specific path, you can supply that path reference and the action will be taken to switch over to that path. And lastly, what type of traffic the action is applied to. We have multiple types of the next update here is while going through the the elements that we needed to model, we discovered that when we're computing with constraints, we wanted some constraints to be relaxable. So in certain cases, a strict constraints that will produce infeasible paths are not desirable. So we wanted a hint kind of to the computation engine so that they can have a fallback option and relax certain constraints. So these constraints we thought are applicable to include and exclude route objects. They can be applicable to other ones. So, but the first ones that we addressed are include and exclude type of constraints. So we are introducing an optimization metric. The computation engine will try to optimize the number of includes. Obviously, if all of them are possible to be included, the computation engine will include all of them. And another one for exclusions, optimize excludes. Again, the computation engine will try to exclude all of them, and if it is not possible to exclude all of them, it will fall back and exclude as many as possible. In the case of includes, the order is independent, as you would think, or the order of listing the exclude resources. The include resources. But in the exclude case, the order is not significant. You just want to exclude them in any way possible. So this metric is just another metric in our objective function. And we're introducing the exclude lists and the include list that will be applicable to those optimization metrics. So obviously, when we're optimizing, a higher number of resources to be included or excluded is preferable in the computation. That's the gist of it. Next, I have the other two drafts that we're driving. For those, in terms of the changes, we have mostly done editorial changes, adding references and aligning with augmentation to the other model, the TE model. There isn't any major changes that we've done to those two models. In terms of next steps, trying to wrap up, updates to the TE tunnel, we are promising more examples and use cases to be documented in another draft that we're driving. The draft reference is right there. So we'll be adding use cases and examples of how we use this model, the TE tunnel model, with the TE topology model as well, and for several use cases of protection and restoration and even many others. We're hoping that will, clarify many of the elements that we're trying to model and why we're adding them. A detailed definition is also going to be in that added in that tutorial or modeling, tunnel modeling. We are planning to split the document, the TE tunnel document into two drafts, separate drafts, and after that we're going to push for working group last call. The last two drafts, as I mentioned, they're kind of stable at the moment, and they're ready for working group last call. Sorry, maybe my voice was not clear before. I don't know what's going on.
You're having mic problems and trying to fix it.
Yeah. Okay. Yeah, I'm trying to adapt in real time. That was it. Thank you so much for listening. And if there are any questions, I'll be pleased to answer.
Any questions? Yeah, so this work has been going on for a while. It's clearly pretty foundational, important work. It's really good. Thank you, Tariq and the team. And we'd really like to try to wrap it up. We do have, as you mentioned, there's a few things going on. There's the split piece. I know that also there's been an effort to go through the models to make sure that we have a good split of generic and non-generic. I actually found one little nit going through it again. Okay. I had talked to Pavan about it. Yeah, that's not working at all. If people in the room could take a look at the document now and the models now and start doing it, there's a lot of work here. So start doing your review and seeing if you can find anything you think needs to be changed, because we'd like to really wrap it up. Because once the split happens, I think we're going to be ready for Yang Doctor review and moving to a last call, right?
Correct.
Yeah, so yes. We really want to start wrapping this up. So now, if you haven't looked at this in a while, now's a really good time to do it. If you haven't looked at it before, even better. The split's going to be editorial. So the models are going to move and some words are going to move around, but the technical content really isn't going to be changed.
Yeah, the team can start and take a look at the current draft as is, and when we split, it'll be easier also to take another look.
Yeah, and my expectation is as soon as the split happens, we'll go for early Yang Doctor review, just to sort of smooth the process along.
Agreed.
Okay.
Thank you.
Thank you very much.
Next is Igor.
Good morning, everybody. My name is Igor Briskin, and I will present this document. Basically, as Lou mentioned, we have a publication request for the T-topology model, and we are very close to come to the last call for the T-tunnel models. And it is important to understand that topology and tunnel models, they are not very complex model, just very complex model. To fully appreciate the complexity, motivation, ambition of this work, one might think, as I do, about this work as an attempt to produce like a SDN version of GMPLS, basically no more no less, to elevate GMPLS on the next evolutional stage and to cover pretty much all other aspects that GMPLS has produced, including like topology discovery, abstraction, multi-layer, multi-domain considerations, path computation, traffic engineering, applications, and so forth, right? But we also bring other aspects, like, for example, telemetry collection. We're adding things that never existed in GMPLS, like Tarek mentioned, protection commands, switching commands, and we also solve like a few problems that we knew about GMPLS, and we during discussions we would pick up and say, oh, this was a perennial problem for us. Let's fix it. Like, for example, the directionality of the inclusion elements that Tarek mentioned. Okay. So all I'm trying to say is that this is extremely important work because if you think about all the documents produced by CCAMP, PCE, you know, with respect to GMPLS, you would get the idea of amount of all kinds of definitions, explanations, you know, motivations, use cases, and stuff that needed to be somewhere documented. And if we would just put into these two models, which also contain the entire source of the models, okay, it would be extremely difficult to actually finish this work. So what I'm trying to say is that the success of the topology and tunnel models in particular with respect to the transport networks very much depend on the success of this work. We presented already twice, and it's been adopted as a working group document. And basically, in many ways, it's just beginning on this work. There are many definitions and explanations that are required by many people, including even co-authors of the models. Sometimes there is very unclear what exactly we meant by this or that, basically semantics in the model. So there are also a great need of use cases that will explain how this model works, the different guidelines, how these models could be augmented, so forth. So all this work we are trying to put into this document. Yeah, so basically there were no much progress since the last IETF on that because we were focusing on finishing the topology and tunnel models, but there were certain changes that happened. For example, Italo produced the contribution on explaining what protection commands are, what shared protection is, and basically this is our goal, where we start to add more and more definitions with respect to all kinds of aspects, including path computation, optimization, and use cases that involve all of that. People would ask, what does it mean, for example, transitional link that was never part of GMPLS to begin with? So all these things will be defined in this document. Well, I will not try to basically repeat what was presented already, but this document has like three parts. One of them is dedicated to definitions for topology model, the other for tunnel model, and then use cases would basically describe how these models could be used separately and in combination with each other. It is it's very beneficial to use them in conjunction, but it is also possible, and we consider various use cases where each of the models are used independently from the other, regardless whether the other is used or not. Okay, this is all I wanted to talk about.
Unlike usual, you have more time if you would like it.
Well, I just want to encourage people to raise questions with respect of the tunnel topology model. This question comes quite frequently during discussions, but not outside of the design team. So basically, we would want to hear them so that we could put more definitions in different sections and provide, like very, rigorous definitions, which leave no room for misinterpretation. We also are looking for interesting use cases that could be also put into this document.
Yeah, the document is very helpful, particularly for people coming in to the work afresh, and there's a lot of complexity here in the models because we support a lot of different functions, and so having this type of document is really important. And if you are reading the topology model that we were talking about before, the one that's gone to publication request, or you're reading the other modules and something isn't clear, come look here. And if this doesn't help, ask questions, and because the next reader is going to have something similar, and it'd be good to capture the answers, and this is the right place to do that.
Right. Just one more thing that I wanted to add. So Derek mentioned that we introduced like a quite unusual elements into how the paths could be computed for the tunnels. For example, we allow for optimization and not just constraint for inclusions and exclusions. Basically, you can specify strict inclusions and/or you can specify desirable inclusions that would be path computation would follow as much as possible, but also in relation to other optimization criteria. So, for example, the path computation can produce the best possible trade-offs between how many inclusions are actually followed with another optimization like delay and cost and stuff like that. So basically, those things are not conventional. They are not part of current PCE, and basically, we would like to have an opinion as to how this could be aligned, how this work could be aligned. We allow for customized optimization, for customized objective function, which are not well defined, but basically you can pick up various metrics and assign various weights so that the best possible trade-off could be achieved, and I can get not shortest and not a shortest delay path, but something which is the best compromise. Yeah, this is just one example.
Yeah, this is Fatai, so I'm trying to help Yigo to use up some time. Okay, so actually, I think this draft is very useful and helpful for the vendors and also operators to understand how to use the IETF models for the transport networks. But actually, in the SACAM, we also have another similar draft that is transport MBI draft. So I think from the motivation of these two drafts, they have the similar motivations. They both are trying to describe how to use IETF models for the transport networks. Anyway, I think for the Eagles draft, just focus on the T generic young like T topology and the T tunnel. But I think anyway, these two drafts, the authors of these two drafts should have more discussions and coordinations. and these two drafts should not be progressed independently from each other, right?
No, just to make it fair, we do participate in mutual design team calls. So I've been personally taking part in the NBI and answering questions that Italo and Sergio generated. Okay, so and on the other hand, Italo and Sergio and Dieter, they are like quite active members of this design team. They are constantly on our calls. So we do cooperate basically.
Yeah, the hope is that the folks contributing figure out the right split. I mean, these are two informational documents. We're looking to the authors to figure out the split, and if for some reason they decide that it makes sense to combine it, that's okay, and we'll figure out how to run the working group process if the authors think that the split is artificial. Please continue on and continue coordinating. Now, if it makes sense to come to CCAMP and have CCAMP hear this work, we can do that, or vice versa, have the NBI presented here. We'll look to the CCAMP chairs to provide some input there and some guidance. Okay, other comments, questions? Thank you, Igor.
Next is the Yang model draft for requesting path computation. Sergio.
Good morning, I'm Sergio Velotti. I'm presenting the status of path computation RPC on behalf of authors and contributors. First, credits about people that helped this work. Thanks to Carlo and Francesco from Ericsson with the extensive review comments and also proposal for enhancement. Thanks to Michael for his review comments, and thanks to all the people, Tarek, Igor, Xufeng, and Pavan, for the coordinating activity with TM model that help us also to resolve a common issue between path computation and tunnel model. Okay, this is the summary of the changes from version 00 when the document has become a working group. The draft it has been modified based on comments coming from Michael, and the draft has been restructured accordingly to this comment with a new introduction and abstract, with the new terminology section, and a structure of a new chapter with the motivation of path computation. So why a Yang model for path computation request, the interaction with the TA topology, connectivity matrix concept, and stateless and stateful path computation analysis and description of the difference, and the pro and cons. Then there is the path computation and optimization for multiple path section, and then there is the Yang part with a new introduction of the new section for model description and new features, and then the Yang model. Okay, this is specifically about the Yang model. The modification has been done. Particularly has been introduced the synchronization for multiple path, has been added the metrics. We use the metric coming from TA tunnel definition, but it's specific for single individual request, and we added specific metric that can be adopted for in case of multiple requests. There is the capability to return the value for computed metrics that is help comparison of the best solution for the path by orchestrator. And it's, then there is the introduction of IRO and XRO using a grouping coming from TA tunnel. And we clarify an issue regarding the endpoints in case of multiple path, but in case of multiple domain, you have multiple choice of ingress and egress. And so the path computation has to select the best choice, make path computation with all the couple, the pairs of ingress and egress. And this is an issue that was related in the GitHub. Here we synthesize the situation of the GitHub repository in which we can track the situation of the drafts. And basically, we remain 11 open issue, but there are 8 out of these open issue that is in common with the TA tunnel, and we proactively work with them to solve the issue. This is instead a specific point to be discussed and clarified in the context of path computation. So the using of include or exclude topology. If it is useful or not to have this type of possibility in which you can choose what is the best topology, the best solution between among different topology for the optimal path. So the structure of TA tunnels are set up in a given topology. So the topology make the context for all the topology entities. The path computation can be used to select which topology. There we have 2 possible options. There we have multiple requests, one for each topology, and another solution, the one request returning multiple paths, one for each topology. Obviously, the option A is not very good in the context of include exclude. For the option B, the advantage could be that the include exclude topology could be used to select a subset of available topologies. But problem is that how you can reference the various topology entity in the different topology. So the type of identifier, how can be relate one to the other. Okay, next step that we plan to have for this draft is obviously work to resolve the open issue, and in particular we continue per cooperation with tunnel model guys, and try to have more comments from working group, and after a further cleanup of the draft, request a young doctor review, and so we would like to be ready for a working group last call after next IETF.
Excellent. Thank you for the update. Are there any questions, comments? So another document that would be really good to take a look at if you haven't looked at it recently or looked at it before. As you're here, it's going to be progressing, but a little bit behind the prior Yang models, but still it's a good time to look at it and send comments to the list. Thank you.
Exactly. I invite the working group if there is some comments also to help.
You can
us.
invite them.
Yeah.
So if you see areas that you don't think are adequately covered, that's particularly important to mention. Also, we don't have a floor mic, so just feel free to come up here if you have a comment.
No, I just took up a bit from the next.
Oh, okay. Well, with that,
Okay.
thank you very much.
Usually we are on a rush, so I'm not used to a lot of time. Okay, morning everyone. This is a short update on the applicability of all the wonderful models that you have just seen to ACTN. This is a draft that has been recently adopted as a working group document. As I said, motivation of the document is to describe how to use, well, actually, it's a double scope, how to apply existing models to ACTN and define what is, or better, was missing to meet ACTN requirements. In fact, in the next slides, you will see which models apply to which interfaces and which new ones have been defined. This is a 0.01 version, so some changes with respect to the version that the working group adopted. Main changes are the clarification about telemetry, performance management, and abstraction. These sections have been updated and fixed a bit. Then there was, ACTN mostly focus on the MPI and CMI interfaces where we have network models, not device models. And there were references to device models, and those have been removed because they do not apply to the ACTN interfaces. And we added also references to the new work on the transport MBI, which is the technology-specific extensions of the MPI interface and Ethernet models. So these are the two interfaces, the CMI and the MPI. Very short recap, the CMI is the one that is exposed to the network user. Scenarios in which it is used. Provisioning of end-to-end ACTN virtual networks, inter-data center connectivity, and so on and so forth. As you can see here, the one in red is what we added to the CMI. Basically, one of the requirements was to be able to set up services with TE and quality of services constraints. We added a model called the TE service model, TE service mapping, that will be presented later on, which allows to bind a given service to a given infrastructure, in the sense that it is possible to bind the service both either to a TE tunnel or an ACTN virtual network. The other interface is the one towards the PNC, the MPI. This one is the one that is heavily based on the TE topology, TE tunnel model, path computation API, and so on. We have highlighted all the technology independent models, the ones that you have seen, and all the technology specific models, because between the PNC and the MDSC, where abstraction can possibly be not yet done, technology specific extensions could be there. For example, related to OTN, optical, and so on and so forth. To conclude, summary and next step. Summary. This is a document that says if you want to build an ACTN hierarchy and interfaces, these are the models that you should use. Next steps. Most of the models, mostly the ones the MPI models, so TE topology, TE tunnel, and so on, are becoming very stable. The draft is becoming quite stable too, and Any comment on how to progress the work, how to improve it, are more than welcome. Sorry for the voice.
That's great. Comments? So I think one area that's still a little unclear is how we're working on the upper interface, the CMI, and I think there's some disagreement among participants of whether or not that needs to be the ACTN service models or whether we can just reuse the other models. And so that's something that is reflected in this document and is, I think, going to be discussed on the next couple of presentations on the individual documents. And I think we still have to work through that.
What you're referring to with the ACTN service model, the
VN Yang in particular. So the CMI right now, you're referring to the VN Yang document and the service mapping document, while the other interface, PMI,
MPI.
Thank you. You're referring to the Yang models that we just talked about,
right?
And there's a perspective of I think the folks working on those other models that they could also be used for the CMI, and that's this is sort of something that's still open, I think, for discussion in the document, and we're working through, and it would be good to get other people's perspective on it. So read this document, but also read the documents that are coming up.
You'll see in the next presentation that we made the huge step forwards in the VN model.
That's great.
Dhruva will explain it.
Thanks. Thank you.
No expectation on you.
Give me one.
Hi, this is Dhruv from Huawei, and I'll be presenting the ACTN VN Yang, the draft which was talking about, and how it will be used at CMI, and what are the updates that we have done based on the feedback that we got from the last meeting. We have a new co-author. Igor helped us reviewing and integrating this work better with the existing Yang models. So what is this? This is the Yang model for virtual network services at the CMI level. It is aligned to the customer service model description that's been defined in NetMod and other working groups. It works on VN level, so it does VN instantiation, VN computation, VN lifecycle, as compared to doing it on a path or a tunnel level. So it acts on the whole VN as an entity. It also has information about the access point and the VN AP. What is a VN? VN is nothing but a list of various VN members. So it describes how that grouping is done. We have some things like VN compute, where we can compute the whole VN as a whole, and also have interesting things like multi-source, multi-destination problems, which has been put as a requirement in the ACTN requirement document and also discussed in the framework. So this Yang model is basically achieving those requirements and those things that we highlighted in our information documents. So what we did basically in this update, we tried to align ourselves to the T topology model as much as we can. And since T topology model had a lot of constructs that already exist, so we simply use them, simply refer to them, and simply align to them as much as possible. And anything that was duplicated, which was also defined in the ACTN VN model, was completely removed. So what were the duplicated things? We had the concept of assigning constraints, picking up optimization criterias, setting up explicit paths. All of that has been removed, and we simply relied on the T topology Yang model, right? And then we also simplified that though we have multiple types of VN, we can have VN type 1, which is a single node topology, or VN type 2, where you may have an abstract topology at various levels, gray, white, black. But to this model, things could be simplified. So we'll talk about how we have done that simplification and how using a T topology single node abstraction helps us to achieve that. So what were the key things in our model. We have the access information, which is nothing but AP and VNAP, which kind of maps to T topology LTP. We have the concept of a virtual network, which maps to an abstract node in the T topology model. I'll show a little bit more details about that. And then when we have a VN member, which is how the two endpoints are getting connected, that's nothing but an entry in the connectivity matrix of the abstract node. So via aligning ourselves to the T topology in this way, we have kind of removed a lot of things which were we were defining it again in our model, and this kind of works, in our opinion, like it works well with the existing model. So how does that look? This is basically a pictorial definition of what I was just talking about. You have AP, VNAP information that maps to the LTP information here. You have a whole VN. VN maps to a single abstract node. So that if we have a reference to that abstract node, we can define the various properties of this VN using the abstract node attributes, which I will further explain. And then when we have a VN member which connects a particular AP access point to another access point, that's represented as an entry in a connectivity matrix. And any specific information about that VN member can be put inside a connectivity matrix entry. And this Yang model also had a concept of connectivity matrices and a connectivity matrix ID. A connectivity matrices is a global container. So when something is applicable to the whole VN as a whole and doesn't need to be repeated for each VN member, can be put in the connectivity matrices. But when we have a specific VN member detail, that goes as an entry in the connectivity matrix ID. So via this concept, which is already there in the T topology model, we could simply refer to put a reference to the single node topology and try to achieve that information. And via the single node topology, you have the connectivity matrices, which also have an underlay container. And via that underlay container, whatever information that we wanted to represent about the about how the path is set up, what is the path, what is the properties, those things can be achieved via that. So this is an overview of how the restructuring and the major change that we have done with this update. This just shows like our old model. So our old model was there. We were repeating some information like how to set the constraints and what will be the optimization criteria. So those we have completely removed now. And this is the connectivity matrices, which is a global thing applicable to the whole VN. And this is per entry, which is nothing but a VN member. So we maintain a reference to an ID here and a reference to a node in an abstract topology. That's nothing but the VN. So when we are talking about setting a particular constraints, those constraints goes here when they are global. But when something has to be applied to a particular VN, that comes to the connectivity matrix ID. So via this alignment, the model has got simplified quite a bit, and we are not duplicating any information across models. So how did we do that? By maintaining simple references to the T topology model. So we expect that we would have ACT and VN model as well as the T topology model being used in CMI together. And we would have a reference to the abstract node and the T topology ID in when we are setting up a particular VN. And when we set up a VN member, we will have a reference to the connectivity matrix ID, which will have more information about how the path and other things have been set up, right? And we already covered the concept of putting global information and per VN member information. So all of this is handled. So now let me just show you about how we did do this in VN type 1 and the VN type 2. And okay, so in VN type 1, the VN type 1 is basically an edge-to-edge collection of VN members which are set up as tunnels in the underlying network. So as we earlier said, basically what we will do is when we create a VN1 in ACT and VN Yang model, we maintain a reference to an abstract node in the T topology model. When we have various VN members, those are also linked to the connectivity matrix IDs inside the T topology. When we have some VN properties, So these VN properties are set via the connectivity matrices parameters inside the T topology model. So this having this single node mapping to a single node in T topology has helped us to simplify the model. And now let's talk about the more complicated case, which is the type 2 topology, in which the customer expect to see an abstract topology, the VN topology, which is exposed also to the customer. But to simplify the mapping, we anyway always have a single node topology, a single node created. This can be created automatically. It doesn't have to be set by the customer, or it could be set by the customer. But the concept is the ACT and VN model will always refer to a single node a single abstract node topology, and uses the connectivity matrices and connectivity matrix containers inside the T topology to maintain the reference. So though the customer may see this topology, the ACT and VN model always refer to a higher level single node topology, which maintains a relationship via the underlay to the real VN topology, and the VN topology might further have underlay to the physical domain T topology. So via this hierarchy, which is very well defined in the T topology model anyway, by reusing that, we could simplify the VN type 1 and type 2. So for irrespective of what is the level of information that is exposed to the customer via the T topology model, the ACT and VN model always rely on a single node topology to maintain references and get further information about the paths and how the VN is set up, what's going on, and VN status, all those information. And one more key thing that we wanted to do in while we are setting up VN member is we want customer to give us direction on how the paths should be set up. So that, for example, we have a VN member, say L1 to L8, and we suggest that the L1, L8 must go through this this abstract node. So this can be set via the underlay path in the connectivity matrix ID for this particular VN member, and by using the existing concept of the connectivity matrix underlay path, we are able to do that. So the ACT and VN Yang model doesn't have to worry about type 1 and type 2. That also simplified the model quite a bit. And then we had like some of the things like VN compute and multi-source, multi-destination as some of the innovative things that we can do with the ACT and VN Yang model. So this problem basically is when we may have we have a choice between multiple destinations or multiple source, and the customers can CNC can set that, oh, go ahead and set up a VN member, and you have a choice between these source and these destination, and from the network point of view you decide which is the best VN member to set up right now, and that can also further change. So by setting a simple leaf that, oh, you are a part of a group of multi-source or a multi-destination, it is the job of the MDSC to decide which one gets selected. And the selected one only gets an actual reference to the connectivity matrix, because that's something that's actually getting established. Whereas the intention from the CNC can be put in our ACT and VN Yang model as a part of various VN members. But the VN members that actually get selected is the one that has a reference to the connectivity matrix ID. So this has also been explained clearly in the document with some JSON examples of how the interaction between the ACT and VN Yang model and the T topology model is maintained. So just to summarize, what's the role of our ACT and VN model? Well, we still want to maintain a customer view of the VN, have a VN as an entity so that the service model aspects can be easily satisfied. You could still do some innovative things like VN computing the VN as a whole, rather than using a set of path computation and or a set of tunnels. But having the VN as an entity still helps giving the customer a view of VN as a single entity. We also have things like when we are mapping to the services, which is going to be discussed in the next slot, where how do we, when we are setting up a VN for a particular service like an L3 VPN or an L2 VPN or a seamless MPLS case, how a mapping between the tunnels that are being used by these services is maintained, which is very useful to show to our customer that what his intention was with the service model and what is being realized by the MDSC. So that mapping also gets simplified if we have ACT and VN-YANG model. And also the information about the access, the customer access, and when the customer access is being shared across VN, that's where the concept of VN AP comes in. So those things should be mapped in the ACT and VN-YANG model. So this is the simplified ACT and VN-YANG model. You have the access points and the VN AP, a reference to the T topology model, which is the abstract node and the T topology ID. This is the VN. You have the source, the destination, and then a reference to the connectivity matrix ID in the T topology model. So this is just the the VN part. You also have the RPC called the VN compute, which I have not put in this diagram because it's almost a similar idea with setting up of configuring a VN. And multi-source, multi-destinations is also handled via these leaves right here. And the selected one is highlighted via this leaf called if selected. So this is also explained in the document. We still have some global properties here, like admin state, operational state, and some other VN level diversity requirements. So those are still here in the ACT and VN-YANG model. So this update, we basically, the feedback that we got from the last meeting, we have tried to handle that with this update. And we feel that now we are much better aligned with the T topology model. And the T topology model has, of course, a space at the CMI because you need to expose the topology to the customer. But how the ACT and VN-YANG model works well with the existing T topology YANG model to give VN as an entity, as a customer service model entity for our customer to look and visualize. So that's what we have tried to achieve. And I hope that the working group feels that now we are at a good shape for adoption. Thank you. Any questions?
Dieter Beller, Nokia. Can you hear me?
Yes.
Yeah. Okay. We found out that there is another draft in the operations area working group addressing also virtual networks. I'm just wondering whether you are aware of that draft, because it seems that there is quite some commonality between this draft and the draft in the OPSA working group. It's the OPSA working group. The OPSA draft has the title "A YANG Data Model for Network Virtualization Overlay Resource Management."
I feel that we are talking about two different things. If I remember correctly, that document was talking more about network slicing and sort of like. Am I incorrect? I thought that's it was not, of course, in the ACT and VN as we define in the TEAS working group. That's something that those guys are like, coming at this problem in a different way. But yes, we need to coordinate. It's in IETF. We have to, yeah.
When I actually looked into that document, it also defines a traffic matrix. It also defines connectivity, etc. So it looks like there's.
Then I think that's more like a T topology people to handle, and this is good. You brought into TEAS working group. If this is being redefined, I think we need to check.
Daniele, in addition to that, I guess that doesn't deal with traffic engineering.
Oh. I'm sorry, Daniel. I didn't hear your comment.
What?
I'm not sure everyone. I didn't hear your comment. I'm not sure everyone else did. No, I just didn't understand it. If you could just say it again.
Okay. I mean, the Ops area draft. I guess it doesn't deal with traffic engineering, and if it does, it's in the wrong working group.
That's right. Okay. Well, it sounds like a good discussion to have with those chairs and as well as the ADs. I actually was not aware of that document, so thank you for pointing it out.
That was an action point from the chair.
So can you go back to the model?
Sure.
So what's the significance of the bandwidth fields? So you're saying those are the only in the AP.
The AP, this bandwidth field.
So are those the only constraints that you would?
No, those are the things which are like the customer facing access links. So sometimes they were not part of the T topology model. If the T topology model is only the provider view of the network, and if these are the things which are being said by the customer, because these are the links that are owned by the customer. So we wanted to make sure that they are somewhere. If there is a better place to put this information, we are completely okay listening to it. But as far as I understood, that it was not possible to put this in the TE topology model. You can confirm if I misunderstood this. Any of my co-authors can correct that part, and that would be helpful as well. So we'll check that offline if there is anything that needs to be changed.
Yeah, this is Young. Yeah, this one is not possibly defined by T topology because access link is only one entity. Here we are talking about AP and VNAP and then partition of that. So I think customer need to maintain the bandwidth partition, correct?
Yeah.
Yeah.
Yeah, we'll take it offline. I still have concerns about using that here.
Yeah, that's right. I think not blocking in any way.
Any other comments? So this is obviously a pretty major update. Reusing mechanisms rather than redefining mechanisms is definitely a great step forward. I'm interested, how many people have looked at this version? That's a reasonable number. How many think that there is still more work to be done? So it's ready to be, this is ready for publication? Well, if there's no more work to be done, there's nothing for the working group to do. That was a trick question. Everyone's hand is supposed to go up on that one. So clearly, this is the type of work that we should be doing here. I was hoping for people to be interested in working in this. So maybe I'll ask that directly. It can't be trick questions. Can't rephrase things. How many think that this work is a suitable foundation for the working group's activity in this area? I would say it's about the same number as who have read it. So that's good. Before I say the next statement, keep in mind that this is an individual document. If we adopt it, it's a starting point. So it's okay for there to be open issues when we start working on something. That said, is there anyone who has reservations about taking this document in as a working group document? Good answer. No hands up. All right. So I think we got reasonable responses to the first two questions about reading and interest in taking this document on. We'll talk offline, and of course, we don't make any final decisions here. We confirm on the list. Thank you very much.
Thanks for making all the changes, of course.
Yeah, thank you for the big step forward. We will, before we take an action of moving the document forward here, we will have to go off and talk in the ops area folks and just make sure that we're not running into a conflict. This is 6, 7.
Good morning. This is Young Lee. I'd like to present traffic engineering and service mapping Young model. This is actually related to ACT and VN Young model. So we had pretty good feedback. So I hope this one also makes some progress. T-service mapping Young model is basically creating a mapping relationship between various service models that have been proposed in IETF, layer 3 SM. I think that's already RFC, right? And then layer 2 SM and layer 1 CSM has been proposed in CCAM as well. So basically, this model, T-service mapping model, in the middle, basically create the mapping relationship between this various service model and the traffic engineering through ACT and VN model. because as Dhruv explained, ACTN VN model has a good relationship and a reference point to T topology model, as you see here. And then T topology model, as Igor explained, always work together with T tunnel model, so that whatever service model need to be connected seamlessly with the traffic engineering, we need T service mapping model. Instead of specifying some T specific policy or binding relationship, how service should be bound to a T tunnel, for instance, isolation mapping. I want my service to be isolated from other other tunnels, for instance, as those information need to be conveyed. But you can do it at each service model, but service model doesn't have that. So we think that it might be good to have one focal point, or the shim layer, so to speak, to bind all various SM models together in one shot. So that's the purpose of this T-service mapping model. So for example, if we have a layer 3 SM, basically a customer will inject a layer 3 SM model to the provider. So customer basically configures layer 3 VPN service using layer 3 SM model. Say I want to create new virtual networks or VPN. So that's the request coming in. And then layer 3 SM model at the MDSC basically pick up what customer wants, and then auto-generate ACTN VN model, which Dhruv just explains it, so that ACTN VN model interact with T topology model and tunnel model to have the cross-reference as to what customer endpoint is connected to, and which T tunnel model as well. And then basically also T service mapping model. So basically it glued together service model and the T model and using T service mapping model. After the mapping is done, basically customer read this T service mapping model as an operational state as to what is my binding relationship with my service to T. And then as such an ACTN VN also can be read by the customer about operational state of my service connected with the T language, so that it can refer to which tunnel model, which tunnel is referred to, so that customer can understand clearly how their service is created. So this is the young models that we put together. As you see here, we have service mapping here to the access point. Services with service mapping, and then site mapping, as well as is also provided with the proper site mapping. But one of the important things is a map type, which is applied whether we choose layer 3 or layer 1 or layer 2. This map type is very important, in terms of isolation or not. For instance, we kind of specify some example map type. Customer wants to create a VN, a new VN, but I don't want to share with anybody else, for instance. So it's called hard isolation. Those requirement or intent has to be conveyed. Or I don't care whether I share with other tunnel or not, but just give me any tunnel, for instance. So that can be specified as a VN TN selection. And then, or it can be, I just don't want to create another tunnel, but just modify the boundaries of existing tunnel, for instance. So those are kind of the example map type that can be facilitated using a T service model, T service mapping model. So this one is actually dependent on the progress of VN Yang model, and I hope I see some positive the feedback from the working group. And this is kind of the last glue that will really facilitate service model 2 TE and topology through ACTN VN. So I thought worked on this quite a while, and actually this is driven by operator requirement, and we believe that this draft could be a good base for the working group adoption. And of course, the map type, we haven't defined details yet. And also, Igor had a comment previous IETF meeting. We can add a little more specific map type, which may not be covered by here. So we have still work to be done, but we believe that this might be a good starting point.
Any questions? Can you come to the mic?
Yeah, Parviz Yagani, Future Ray. We are actually planning to use both IETF models, the work that you guys are doing, in ONAP. So that's good news. We are also working with MEF LSO. So I'm trying to figure out, is there an overlap between the two, or you guys you have been looking into MEF LSO versus the model that you're developing here? Just a clarification.
Yeah, I think LSO, if I understand correctly, they have Agato interface. Yeah. I think maybe CMI is kind of similar, but I don't think they have clear, work progress as far as I know. Yeah, no data model. They're just information and architecture, and this is another step further. But we are IETF, and then we have all the service model defined here, young models already. So I don't think we need to be too much concerned about MEF. But if MEF wants to have liaison relationship with us, we can actually provide young models for them, so that IETF model can progress further into other SCOs. And like MEF or Liaison CSM model, service definition, they actually make a liaison with CCAND, and CCAND has young model already, so that's work in progress like that. So I think this might be another liaison if they want to use IETF model. But as Jeff said, they're not talking about young data model yet. They talk about info model, so I don't know where they are coming from.
There's another more fundamental problem. MEF models are not open for people who don't participate in MEF, and hence of no use for us.
Right.
And eventually, I think they'll be using IETF models because someone has to write the model.
In general, I do think that this working group should look at working on a generic TE service mapping function. At this point, I'm still trying to figure out whether this needs to be done in a generic fashion. I don't see the reason why this needs to sit under the ACTN umbrella. But let's see how the previous document progresses.
Yeah, actually, this is not ACTN umbrella.
It does, but if you read through the draft, it's very much tied to ACTN. Okay. But let's see how the other document progresses, and then we can revisit this.
Okay. Yeah, that is helpful if it just makes it clear that it applies to all TE.
It is. Yeah, actually, we need to take our ACTN, but we use ACTN VN model as a connector to TE model.
It's okay if you reference a document that has ACTN in the title, but...
No, actually, we don't have a title ACTN, actually, if you read carefully.
If you go back to the slide that ties...
go back.
Yeah, actually, there's a slide.
Yeah, can you go back to the slide where you where you have the functional blocks for... Keep going back. Yeah, this slide here. Yeah, I don't understand the box with ACT and VN in there.
Because I think, as Drew explained, that's a very simple way to connect.
So yeah, I mean, I understand that this is saying that this is how you map onto an ACT and VN, but I would like to see a generic discussion on TE service mapping.
Okay, yeah, that's fair. Yeah.
This is Drew. I think one confusion here is that when we were writing this document, we were focusing on the CMI side. So where we are seeing the actual L3 SM model and the service model being mapped to a single thing. But at the other level, what will happen is when you look at the device side, and maybe you have configured a VRF and you want to bind it to the tunnel. So that model is a little bit different because that needs to be looked at. Your mapping is on the device, what is the tunnel that I'm actually using and how it is mapped to VRF. So I think it's good to differentiate for us when we are looking at the service model level and whether we are looking at the network and at the device level. That's where our thinking was. So maybe let's see if there is.
Yeah, I mean, right now the way the draft is written, it's very specific to, yeah.
Yes. I would
So
like
if-
to clarify, it's for CMI, right?
Yeah.
I think this goes to the disconnect that I was talking about earlier, where some see TE topology as equally applicable as a service model as it is on as a device. And I think we have a difference of perspectives here, and that we have to work through as a group. But I think that's what's going on here is that we have that disconnect of perspectives. So we can have more discussions here. That's good. No, continue. Come to the mic. We can have more discussions here. So let's continue with that. And then, but also I expect that some amount of getting together offline, hopefully this week, might be necessary. But I wasn't trying to cut off the line. We actually have time to keep discussing the topic.
So just to answer that question, in this model, if we don't want to go via the ACT and VN and directly want to refer the T topology abstract node, nothing is going to stop you. We can easily update that. So we have no issues with that. So, but this should be CMI level. I think the difference here is when you're looking at mapping at the L3 SM, that has to be at the higher level, and the mapping that we have at the VPN and the VRF level has to be separate. So I wanted to just make sure that we are not. But your other question was completely valid. We can look at how we can map directly to the T topology. That's not.
Okay, that's good to know.
Hi, this is Igor Bersin-Hove. So I'm, first of all, I fully agree with Pawan. The service mapping problem, it has to be solved in a general way. We have, for example, we have like a lot of discussions in Ethernet layer and how to map, say, EPL services, EVPL services, or ELAN on the tunnels as well. And it's almost, verbatim the same issues as you have here. And I would say that the T tunnels and topology, it's something which should be, in my opinion, decoupled from the services. And I would follow, for example, what layer 3 services, layer 3 service model has produced, right? So basically, you have one model which is service model, which is network-wide model describing a service like layer 3 VPN network-wide. Then you have another model which describes a device-specific model, how to map, for example, service on a particular PE with respect to the tunnels. And then there is a totally separate model, which is the tunnel model, which basically serves the services, and you can map various services on those tunnels. And T-policies is just one part of the service mapping. There are other policies which could be also considered as well, and this is not our job to discuss, but for example, how do you constrain the connectivity, what kind of label mappings on the edges, stuff like that, right? How you, for example, translate VLAN IDs coming from customers into VLAN IDs going onto network. Those are very generic issues that needs to be actually discussed as a separate issue. It would be good to have like some kind of service independent agnostic model that provides like various divisions like T policies, like connectivity limitations, so forth. But I would strongly suggest to actually decouple the T tunnels from the services. T tunnels, that's something, that infrastructure that serves the service. Like for example, there could be a layer 3 VPN which is delay constrained. Okay, so and the customer say, I want to have layer 3 VPN which has like this kind of latency. The only way to produce it for the operator is to come up with the T tunnels which are properly optimized and constrained, so that the piece will be connected with certain tunnels, right, with certain constraints. But those tunnels can serve other services as well.
Yes, I think I agree with you. So this one is basically what layer 3 VPN guys say. I want to have ultra latency, service, say, 10 millisecond, and then it has to be deterministic, for instance, without any variation of Q delay, then this one accepts, and then make sure that the TE tunnel will be created as such a fashion, and then let customer be able to monitor in a closed loop through a telemetry model, so that they understand, what they have requested is instantiated in the proper way. So those things actually, this one actually provide that glue, so the customer can understand what is going on. So.
Yeah, so one thing is that sometimes it sounds like duplication of what you specify as a TD policy with this, what do you specify as a T constraints or optimization, but in fact it's not true. Say the customer may say, I want to have, say, 99.99% availability or basically diversity of these two services. And this could be translated by, to say SRLG disjoint, right? But customer doesn't know what SRLG means, right? He doesn't have no clue how SRLG is assigned, or what does it mean, whether it's a single cable or single building or single geographical area. He only cares about, like availability. And this is something that he can come and sue, say, operator for violation of the services, right? And it's the job of service mapping into particular constraints and optimization as to how the tunnels could be actually set up on the provider network.
Adrian Farrell. So I think Igor nailed it there, and the generalization of that statement is that the service is not aware of, or the service model is not aware of the content of the network, and somewhere you need a model that is aware of the content of the network. But there may also be a little loop round in that as you stack networks, which is what ACTN is about, the TE tunnel request at one level may become a service, if you like, a point-to-point connection service request back down to another network, and then the whole thing recurses.
Yeah, I think that's exactly why TE service mapping is needed, because service model doesn't address how TE should be constructed. That's why this is gluing between these two worlds, so that customer can have a visibility of underlay and monitoring capability in the closed loop. So that's the purpose.
To rephrase, it maps service level just into not networks. It maps service level objectives into physical artifacts of the network.
Right, that's what it does.
Yeah, it sounds like there's been there's an opportunity for some really good input into this document.
Sure.
And so if you can try to work with people who made the comments, capture that.
Yeah, we're going to work with Igor. So we do the VN Young model, okay, to generalize it, okay?
Yeah, and take into account what Pavad was saying, and Adrian. I think Adrian actually hit, he had a point that I always go to is that recursion piece.
Sure.
And so these are really good things to capture here and really important.
Right.
And with that, I think we'll have some really good work to bring to the working group.
Okay. Okay. Thanks.
Thank you very much.
Igor?
Yeah. So we're still just a little bit ahead of schedule. Igor, actually, he has up for 2 slots, but he's only going to be using one of them. So Igor, you could take the 20 minutes, or you can take less.
Yeah, that's very generous.
Usually we cut Igor off
so
this time he gets extra.
You're catching up, yeah.
Before you jump in, where are the blue sheets? You see the blue sheets? Who needs the blue sheets? So if you could pass them back to those people, thank you very much. We'll get a bigger room next time. Good. Thank you.
Hi. So this is the work that I'm personally very excited about, and so do my co-authors. And we have a new co-author, which is Jeff Tensura, who is also very excited about this work. But unfortunately, people outside of this group, we failed kind of to get the same level of excitement so far. Okay, so and that's why basically we have no any progress on the model that we actually wrote before Singapore, and it's fully it's actually written, and it's quite good in my opinion, right? But we need obviously some other comments on that, and I think we have the same issue. I hope that we have the same problem as steam engines, right? Which were appreciated not when they were invented, but when the era of the steam engine arrived, right? So what we're hoping that era of software-aware topologies is rapidly arriving in a form, for example, as network slicing and stuff like that. Okay, so we basically concentrated on the use cases to bolster our story, kind of, right, and to get some more excitement from people. Yeah. So basically, just to remind what is the whole idea of this work. 20 years ago, if you look at the network, it basically it was just a topology that would explain how the connectivity services could be provided on the network. How do you get information from point A to point B across the network, and then it would have some kind of T parameters, attributes that you can constrain the path selections, stuff like that. But everything was limited only to the connectivity, right? So and network today is a very different animal. So network provides not just connectivity services, but many other services, service functions, network functions. And for the client, it is very important to see not just the network topology, but also what is available, what kind of services the client can outsource, you know, and it sees the service not just like a connectivity, a connection or a tunnel, but a change of such tunnels which properly constrained and optimized and connect properly selected network functions, so that the data is not coming from A to B, but experience certain processing and so forth, right? So so we see it's important to provide information about not just topological elements, but also the service functions available on this network, and importantly, how they are related to the topology. Where do this service function live or can live? And so that the user can have a say as to how the service function chain, not just a tunnel, could be created and optimized. So things like that. So graphically, the service function aware topology looks like it is on the picture now. So it's you can see it, for example, like a T topology with T nodes hosting various service functions, and then we find some components of the basic T topology very useful to describe, for example, which service functions are available on which nodes, and applying connectivity metrics concept to describe how they and whether they could be connected and at what cost. Just to remind, the connectivity metrics basically is used to describe the nodes switching limitations and capabilities, right? So how you can connect, say, LTP1 to link termination point 1 to layer LTP2, and the detailed connectivity metrics basically augments this information with a vector of cost. At what price these LTPs could be connected, so that path computation can include penalties going through the nodes in the evaluation, for example, and using optimizations based on different matrices. So what we decided is why not to imply connectivity metrics and in particular detailed connectivity metrics for service functions and describe which service functions could be connected on a given node and at what cost. For example, what kind of delay would introduce connecting SF1 to SF2? What kind of bandwidth limitations, how they could be protected, stuff like that. And then we also can provide the similar connectivity matrices to specify which service functions could be connected to nodes, link termination points, and tunnel termination points, so that various service functions could be interconnected not just on the node, but across the network, right? Via LTP to the neighboring node, and via TTPs, service functions could be connected, located anywhere in the network. So now, basically, what happens is that the path computer, having this knowledge, can do what we call dual optimization and optimize the selected service function chain on two criteria: on the location of service functions as well on the tunnels interconnecting them. So, and there could be a pretty good idea how what kind of end-to-end delay could be for entire service function, as well as, for example, between the neighboring service functions. Okay, and as we discussed, as we presented in Singapore, right, there could be various interesting use cases, like, for example, how can you say do proper optimization of T-tunnels so that the proper constraints could be satisfied between two neighboring service functions and end-to-end? How can you protect a service function if a node or a function fails? You know, how can you go from, how can you do load balancing and things like that? So it's pretty interesting concept, and in my personal opinion, it's almost perfect start for network slice. So I cannot see of anything better than to describe network slice than sort of function-aware topologies. Okay. Now, Yan Lee, one of co-authors, came with an interesting idea. He said, why stop on service functions? Why not to shoot us into the application strata? Okay, and basically describe how applications can make use of information about TU they work on. And there are various applications that could be considered, including, for example, various web caches, like a content network distribution, right, like a CDNs. And my personal favorite, it's a high-frequency trading application, which, you know, since I have a bit of luxury, I can entertain a little bit more on that. So basically, imagine that you have a multi-layer transport network which is optimized to absolute extreme on time. Okay, I was shocked personally to know how much money you can make if you have, say, advantage of several microseconds. Okay, then imagine that you have multiple applications, like, for example, brokerage, which originate various trade requests, and then exchanges running matching algorithms which find buyers and sellers according to certain algorithms, right? And then you have also what they call dark pools, which is like a constrained exchanges for only constrained users. And then you have applications which define fair market price, which you know, put certain constraints, regulatory constraint as to how this matching should be done, and so forth. And obviously, the name of the game is speed. So how quickly you can learn information and how quickly you can react on that, right? This would give the client, for example, the idea where to put the application to begin with. There is a very expensive but very profitable potentially service that exchange can provide to a client by allowing to what they call collocation. To collocate their, for example, brokerages next to exchanges, right? And then you can have you can know how to optimize your transport network. Some people, for example, replace lambdas with microwaves just because microwave have speed of light and fiber doesn't, right? It has only a fraction of that. So things like that, right? So, and basically the whole idea is that in ideal world, these prices and these trades are done instantaneously, but there is always discrepancies between the current price and, for example, on one exchange and the other exchange, and the price of a stock and its derivative, like say option and future, and people put in morale aside, okay, but it's totally legal to exploit these discrepancies and loopholes, and the client can get a lot of advantages just looking and optimizing this network and use the knowledge into what they call their routing applications that route their trade requests and distribute it in the most optimal way between available exchanges. So this is just one way how the model could be used. So if I'm hired, for example, for high frequency trading, I would actually, promote this kind of model to work on the advantages and basically how you can get advantage of this model. Okay, so right, so as I said, we did wrote the model, the Yarn model for that, and but there are certain challenges that we have. For example, we rely on the ETSI definitions of the services. Okay, so far we depend on them, and we try to be dependent on them as loose as possible. We just use service IDs and service instance IDs like opaque numbers, but interested client might want to understand what the services are, especially to understand the extent of mutual substitutivity. For example, if I want to have a failure on one node of a certain function and I want to go to another node, so I need to understand how similar these functions and to what extent they can substitute each other, right? So the problem that we have is basically egg and chicken, right? So on one hand, we were told that we cannot define the services ourselves because that's the job of ETSI. But for example, on the other hand, ETSI is not quick enough, right? So the progress is very, very slow. So what can we do about this? So can we, for example, issue a license as we do to ITU or stuff like that, or not? But in order to get to this stage, right, we need to have some sort of interest in this whole. So, and I hope that network slicing will actually produce sufficient interest and sufficient power that we can leverage such instruments, right? So one of the co-authors, Luis, I don't know whether he's in the, he mentioned that he would bring this model into network slicing environment, and we will try to do our best to actually use this as a very important use case for this model. And once we get to this point, obviously there will be various comments and recommendations as to how to modify or augment our model. That's it.
Question?
Question.
Tarek from Cisco. Hi, Yor.
Yes.
If you go back to one of the figures that you had, you were showing us previous. So the service function, the way you've modeled it, is a property of a node.
Yes.
Do you think the service function can be a standalone kind of function element in your model, not hosted on a routing or switching switch or a node, sorry, routing or switching node?
Yeah, you understand that node is not a switch. It's basically it could be anything from a domain, or it's an abstract node. Okay, it could be a physical switch. It could be a part of a physical switch, as we discussed, right? And the reason why we make it properties of the node that when we use connectivity matrix, which is, by the way, a property of a node, right? We use like several connectivity matrices. One of them to describe how the service functions could be changed locally on this node, right? But also, very importantly, how these service functions could be hooked to the link termination points of a node, tunnel termination of a node, so that they could be connected across the network. Okay, so in order to combine, for example, T-links, right, with the service functions and their costs, right? So we had to go this way. If we would produce like a separate node, it would be a totally different picture. And personally, I don't see an advantage to that, right? I would actually add even applications as attributes to the node. So the node could be, for example, a data center.
I see. So the node is not specific as a routing or switching node. It's any abstract node.
Yes.
Right.
Yes. In particular, and most importantly, it could be, say, data center.
Okay. Thanks.
Yeah, this is a quick comment for clarification. So I think some examples on the service function you listed in this chapter, including, for example, firewalls, TPI. I think they are all applicable for the packet network. So my comment is, if the service function aware topology can also be applicable for the transport network, for example, OTN, WSAN.
Yeah, excellent question. So in the draft, we actually have use cases which try to illustrate that the service functions and network functions in particular may apply to a transport network. For example, you may think about network function as 3R generator, right? And you can, and normally people would put 3R generators in like strategic pools, like I said, strategically placed over the network. And this would make for T application, very interesting T application where you can assign dynamically regenerators without having operators to explicitly specify where they, for example, based on optical impairment consideration. Okay, so this would be one use case for like a layer 1, layer 0 network function. The other, there are other examples, like for example, certain OEM capabilities, they require certain hardware support in the OTN network, which is not readily available on all devices. This also could be modeled, that's what Martin Wizards actually suggested. They also could be modeled as network functions, which, so basically only certain, but not all network elements will have such possibilities. And then you can route your tunnels in such a way that OEM will be like a most feasible and most efficient.
Yeah, okay, thank you. So could you add this kind of examples in this chapter to make people have clear understanding?
Yeah, there are use cases. I believe 6 or 7. I don't remember, which describe each such use case separately.
Himanshu from Siena. So you have an SFC with the T constraints. What about the service constraints themselves? So, you know, the replications of the services, availability of the services, and things like that. Does that affect the topology?
No. The whole point is that we're trying to build this model as an augmentation to T topology model, right? And this model will provide the identity of the functions that are available on the network, as well as the constraint as to how these functions could be connected locally and across the network.
Right, but say for instance you have a firewall, but that particular firewall on a particular node is utilized 90% and you only have a 10% availability. Now there could be other places where the firewall is available. Right. Does your topology change based on the service availability and the percentage utilization or the availability of the service itself? Not, you know, that you have a T constraints, you know, how quickly you can get between the services and delays and all that stuff.
Right.
But I'm talking about the service itself. Is that taken into consideration?
That's an excellent point. So basically, so far we haven't considered the attributes of the service functions per se, because we hoped that by looking up definitions defined by ETSI and the models like Tosca model, stuff like that, we could get such information. But we might add actually the resources that are available on per service function basis. Partially, we consider that because when we say connect service function 1 to a tunnel termination point, we specify at which bandwidth it could be connected. Okay, obviously it cannot be more than bandwidth available on the function itself, right?
Right.
But it probably could be a good idea to have that, to separate the connectivity versus the actual resource available of the function.
Yes. Oh, right. I
Okay,
think that
we'll
should be-
consider that.
Yeah.
Parviz Yagani, Future Way. Yeah, this is interesting because we are looking into separating the service layer and primarily you define information model. I don't know, Igor, you have looked at it or not. The information model includes the service function and the topology, the graph.
Mm-hmm.
And that graph basically primarily drives the service layer connectivity, not at the network level. Now, there's a separation of the information model from the data model that drive the actual network. Are you planning to separate those two layers? Because I guess it was, sorry, for someone mentioned that if service function is an attribute of the node, my opinion is the no. That service function, that layer is different from the actual network connectivity, because if you want to really connect those points together, you need to define like a data model. You mentioned Tosca, yeah? So you want to map the Tosca at the service layer into a data model. That data model could be specific to your underlying network, okay? For example, if it's a layer 2 network or a layer 3 network, is that separation is already, I haven't read your draft yet, but is that a part of the scope of your draft or not?
What we are trying to achieve is that we want to decouple service models from basically the topology models, right? But we also want to combine them together in a way that you can do this dual optimization. So it doesn't matter for us whether it's Tosca or not Tosca, it's ETF produced service models. As far as there could be some ideas that could be used to interconnect these models. I personally do not like very complex YAN models, which with mount points, stuff like that. I prefer much better to have simple models that could be interrelated based on like IDs rather than through say XPaths and stuff like that. Because one reason is that some clients may be interested for certain things, but not others, and they don't want to bother with like a very large and complex models. So if I am only interested as to how service functions could be connected, but I'm not interested what exactly they are doing, that's possible. But if I want to also understand what they're doing, that's also possible, but only for interested in us clients. Okay, so
keep in mind where we are right now is looking at the use case document, not the solution document. So before we even get to solutions, we have to agree on the use cases, and we've actually managed to fill up both time slots. We had one more question from the floor. Jeff, go ahead.
It's a good thing.
If it's about a solution, don't talk about it, please.
So just there's difference between network-driven application and application-driven networking. And you should look at it from perspective of network-driven application. So imagine it's front haul and you have particular constraints. This is where it's going to play. We don't want to mix firewall capacity with, with stealing.
Right, and that will be very good to capture in the use cases. No, in the use cases, if that's what we want to be working on. Please, last comment.
Kiran from Huawei. My question is also solution related.
Then we can't. Then we shouldn't talk about it now.
5 words. Is it related to NSH header in some senses, like 3 constraints will be mapped to NSH? Any thoughts on that?
No. Please answer that offline.
Yeah.
Okay.
But that
So with that, with
what-
that, keep in mind that we're talking about the use cases here. And the question for the working group is, does this working group want to work on this type of, these types of solutions? And if we do, talking about identifying what the use cases are is a great place to start. So the first question for the working group is, do we want to be working on these types of solutions that Igor's been talking about? I think we've got some good support on that. How many people think that the document that was presented is a reasonable place to start the discussion on what are the use cases? I would say the same number. Note that I did not ask how many have read the document, so I will ask that now. How many have read the document? Slightly more than the previous two, but the previous two questions I think, had good support. Thank you very much. We'll talk offline in the chairs, and I assume you'll see it on the list.
Thank you.
And Igor, thank you for putting us back on time. With that, we're going to jump to the next slide. Oops.
BRT.
Beer TE, Corliss? And if we can do 15 minutes instead of 20. Sure. Thank you.
We've got this beer working group where we've been defining new multicast forwarding. And I wanted to give a quick background of that. So the state is that we've basically finished the definition of the shortest path forwarding model, which we call BEER, and have adopted the forwarding plane model for the hop by hop controlled forwarding for traffic engineering. And with the working group going more towards standard track now, we are also asked to follow the standard track way of splitting up the work into the appropriate working groups. So for example, any future IGP work which we've done in the past in the beer working group itself would now be an LSR, and likewise the architecture for anything about the control plane architecture of traffic engineering in beer TE would have to be in TEAS, and then obviously spread out into PCE, LSR, or any other working groups where we would want to have the specific drafts done in. So next slide.
You have a clicker somewhere?
The clicker. Right, so let me give you quickly the background here. Traditional multicast problem. So why are we doing beer? The problem in multicast is that instead of simply having prefix or SID forwarding entries that are the size of your network topology, in traditional multicast, you have a forwarding and control plane state that you need to build on every transit hop in the network, which we call multicast trees. And the number that you need is, the possible number of sources by the possible number of subsets of receivers in the network. You have 50 receivers, worst case, and 10 sources. You have 2 by the power of 10 times 2 by the power of 50 different trees that you need to build, right? And, operators weren't really so keen in managing all these trees in the network. So that's basically the root cause for going to a model which, similar to segment routing, tries to avoid having state in the network. And it's even worse in multicast because in segment routing, it's still only about the path topology and the number of paths you want to have. So it's really independent of most of the application specifics. While in multicast, it's very naturally based on how many applications you're running. So this is basically for later reading, right? So I didn't want to show all that stuff. So with beer proper, there is no state in the network anymore, right? So basically, I'm not sure if it's appropriate, but let me try to explain it in terms of segment routing, right? So imagine that instead of simply having, the LDP-free network with, a single label to indicate a receiver in the network, now basically in your packet header, you have just, a sequence of all the possible receivers you want this packet to be received in, right? So basically you want to send it to P2, P3, you basically put the SIDs of P2, P3 in there. And let me see if we can actually have this. So in P1, you're looking at the packet and you're saying, oh, wait a second. So I need to send it to P2, P3. So let me make one copy to every interface where I have from my routing table at least one receiver there. That's pretty much what Beer does on every hop. It basically looks at all the destination addresses and figures out, okay, which interfaces do I need to send one copy to? Every interface where I have one or more receivers behind it. And basically, you know, it's just routing on the shortest path. Okay, you say. But if I have 20 or 128 bit for every address, the header gets fairly large if I want to address something like 50 or 100 receivers, which is why we're simply addressing every receiver by a single bit, right? Our address space is from address 1 to address 256, or could get as large as 1024 if your header is 1024 bits. And that's basically what we're showing down there, right? You've got the Beer header, and here you see 2 red bits. So bit number 2, okay, this packet needs to go to P2. Bit number 3, green, right? 2, 3, and 4, and 5, right? So basically, you know, you can compress addresses down to bits if you don't have that many. And well, if you now have something like maybe 1,000 PEs that you need to target, and you only want to, you know, have an overhead of 256 bits, well, what are you going to do? You're simply going to send, well, maybe 4 packets, right? So yes, Multicast originally said 1 tree is good enough, but when the trees actually become a problem, maybe it's less of an overhead to basically instead say, well, I'm still getting a benefit of 256 times less data to send, so why do we need to do more? So basically that's why, you know, the bit string length we support, typically 256 bits for Beer is seen as good enough, and otherwise you'll send more packets. So this is basically, you know, the typical shortest path architecture. So the path engineering that you can do in this environment is typically based on a really nice ECMP architecture we have there, and based on, you know, using all type of different topologies of an IGP and engineering your IGP, but it of course doesn't support the typical explicit path setup that we're known from RSVPTE, or that we can do in segment routing with specifying also a label stack with intermediate hops. So that is exactly where TE comes in, Beer TE. And so in Beer TE, the bits are not indicating only the receivers, but they're simply indicating the interfaces on the paths themselves. So for example, with the same type of trees, the red one S1, G1 going here, basically you would need the following bits, right? From the sender, you would basically say, okay, this interface here is bit number 2, this interface 3, 4, 5, and you would basically just set 2, 3, or 5, those bits in the Beer header to get basically the packet passed over this non-shortest path here and then replicated here. Likewise, the other examples, right, you just assign bits to every interface. And again, like in the Beer case, 1 bit for every address you need. The big forwarding difference is simply that in Beer, you're looking on every hop in all the destination addresses and trying to figure out where to send it to. And the logic in Beer TE is very simply that you simply need to look only at those bits that you have direct adjacencies, right? P1 would never bother looking into whether there's another copy going up here over bit 3, 4, 5 or so. It's just simply ignoring all the bits that it doesn't have direct adjacencies for, right? Otherwise, it also in parallel looks at all the bits and individually creates copies for every bit that is being set, and that's a direct adjacency. So that's basically the simple rule. Now, obviously, there is the good discussion about what is the bit overhead that we have, how large can the topologies become. The forwarding architecture has a lot of details about that, and so there are a lot of tricks to reuse the same bits in different parts of the topology. I was just here showing a simple case that obviously on a point-to-point link, both sides can use the same bit, right? So you just need 1 bit. In the same way, a LAN can use 1 bit. A ring could use 2 bits for, you know, clockwise and counterclockwise. So a lot of options to optimize the number of bits you need for intermediate hops to steer the traffic through the topology. So maybe we're getting up to, if you have 256 bits, maybe you still get, you know, 50 to 100 copies being sent out over the engineered path, and the rest would be the path bits that you're interested in. So 2 more things, finishing up the architecture. So the routed adjacencies, and there's a picture later on the presentation to give you an idea, is exactly to even further simplify the number of bits that you need. And that's really if you want to build an overlay topology where you're saying, I really only need replication a few points in my topology that I want to steer traffic through. And basically in between that, I'm not going to do hop by hop path with beer, but I'm just going to build, for example, segment routing tunnels between the different replication points. And that's what we call routed adjacency. You have some bit, you replicate, but you don't send it to a direct neighbor. You send it through, an adjacency which you have predefined to be a segment routing tunnel. The other part is that one of the interesting use case areas that we're targeting with the BRTE is DetNet. And in DetNet, there is a functionality called packet replication elimination, which basically is about the fact that you want to have traffic engineering to build dual non-overlapping path through the network to send the same traffic twice, and on the receiver side, eliminate the duplicates, and therefore creating a highly resilient architecture. So there is in the drafts that we have up for this in the BEER working group, some interactions between BRTE and this, and obviously, given that the resilience and not only the path selection is a key part of the DetNet use cases, we felt that for the framework of traffic engineering, we wanted to include this resilient functions as well and appropriately figure out how to basically provision and manage them. Okay, so how do we do the traffic management in terms of, okay, how does it work from the traffic perspective? And so I was trying to show here the starting point. There is not that much documentation about this in the 0.0 version of the draft. But if you think about it, right, in BEER, how do you create a bit string? You create a bit string by knowing on the sender what are the receivers I'm interested in. Each receiver I have a bit for, and I'm just ORing the different bit in the bit string, and then I send off the packet into BEER. Right, so basically it's getting replicated to all the receivers. 1 bit per receiver that I need to remember. Now in BRTE, if I do pre-calculate paths that I want to use, ultimately what you're ending up is you have from a particular source to a particular receiver just a bit string with the individual hops that you need to go through, and you can equally OR them, right? So if you say, oh, I have pre-calculated on my PCE controller, for one particular set of applications, the set of path, then it's basically one path from every particular source to receiver, and the source can basically OR these paths together to basically multicast the packet. So from that perspective, there is a really nice, easy way to basically create pre-calculated path where then the sender can individually still, if one receiver joins and leaves the multicast group, he doesn't have to necessarily go back to the PCE controller. Subject to bandwidth management, of course, they're really fun, minimum overall cost. They're called Steiner trees, which means you remove one receiver, you need to recalculate the whole path, obviously somewhat different. But if you try to do the same thing with RSVPT point-to-multipoint, well, you have to do a lot of resignaling. And here, in BRTE, it would simply be a local calculation on the sender, and voila, you send off a new packet with a different bit string and get a different tree cost.
2-minute warning.
Yep, so that's short. Okay. So this is basically the overall architecture that we're proposing with all the underlay. Here's basically the BEER stuff, and basically the signaling to a PCE controller provisioning system. Let me quickly try to go through that. So what we've been trying to figure out in the 0.0 draft is how to provide a framework where we can use the PCE controller for everything, or just for the provisioning, then using the IGP to disseminate the information for diagnostics, for basically automatically overcoming inconsistencies, and then also to enabling the sources to actually calculate path if that's desired. So just the framework, what these different things. And so one of the next steps is then figuring out, what type of data models do we need to build out in Yang. So what the rest of the slides here is, and I think we're running out of time, so maybe take it up next time, or maybe, in the PCE working group, we're also presenting, so we can go into more detail there. Let me skip through those details. But here's basically kind of 2 slides about the data model that we think is going to be the target for whether we're going from a PCE controller or the same information to put in an IGP. And yeah, so we basically would like to start, going forward with the framework, figuring out what pieces are missing in the framework, and then basically identify what the next protocol steps are, like the Yang model, the LSR extensions, and yeah, get the guidance from the TEAS working group on, how to do that work in, the process that the IETF established, right? So running around between all these different working groups, how to do that correctly to process, right? So any guidance?
Yeah, it may have been a little quick, just because we didn't have a lot of time, and appreciate you cutting a little short. There's actually a lot of commonality here with what we're doing with any controller-based path selection and control. It's just that the way the control is instantiated is in the data plane rather than through control plane signaling. So there actually is some really good overlap with the work that's going on here. So it's definitely worth looking at this document if you haven't, and I think you'll be surprised to see the common ideas. How many people have looked at this work? That's actually a reasonable number. And how many more, if you didn't raise your hand before, are interested in hearing more about it or pursuing it in this working group? So a few more hands. So, it looks like there's some good interest here. Maybe it's a little early to try to go for adoption, but you're not asking for that. So that's okay. So, I think that there's good alignment on the technical side. There seems to be interest here. So thank you for bringing it here.
Okay, thanks.
Hi, this is Dhruv again, and I'll be talking about hierarchy of IP controllers. So basically, this is not something new. The idea here is basically to kind of capture what we have already developed in the TEAS working group with respect to ACTN and the various TE Yang models, how they actually get worked in a real IP controller, where you have TE components and the non-TE components, and you have various other protocols that are running. You are using PSEP, Yang, BGP. There are so many different things that we have been working across in various different working groups within TEAS and outside TEAS working group as well. So how they come together, how ACTN framework that we have developed get applies in the IP controller case. So those are the things that we have tried to capture in this document. And it's an informational document. It covers basically various interactions, talks about other protocol considerations, talks about the services that we offer, the IP services, and how are they realized, and also notes if there is some missing pieces. That's something that we need to work on, which is not currently captured in the existing solutions there are. So nothing new here. You have the domain controllers. You have somebody like a supercontroller. A supercontroller receives the request from the customer, breaks down into tasks that each domain controller has to take care of, and it does the coordination function, something that we very well know in the ACTN and this working group. So the main thing that we wanted to capture was that what we define in the ACTN basically are some functional blocks, and these are the functional things that any controller needs to implement. So within the controller, you may have various other functions, and the ACTN part is just the functional block, which is nothing but our MDSC and PNC, and those are the functional block within the physical controller that packages multiple other functions. So you have your MPI interface, which is focusing on the TE part and the ACTN part, but you would also need various other non-TE interactions to actually get IP service established. So this was usually because there is, when we talk about ACTN, there has been some confusion with respect to what is the real value, how does it actually helps in setting up IP services. So that's why we thought that writing this information model and capturing those things also would help to realize that inside the hierarchy of IP controllers, how it is being used. And we also try to cover the interactions between the non-TE parts. So for example, is there any interaction with BGP? What are the set of other Yang models? How do we do OAM after the service is established? All those things we want to capture. This is just a 0.0 version, but that's the vision that we have with this document. And focus that when we say MDSC and PNC, we really don't mean the full controller, but only the functional block which is doing the ACTN functionality. and then you would need a lot of other things. This is not new. Even the ABNO and the other work that has captured that even the PCE is just a functional block within your controller which does the path computation, but you would need multiple other things to actually establish a service using this architecture. So in the next slide, I'm focusing on some of the key concepts. This did not change. This remains exactly what ACTN described. We can implement it via various different mechanisms. The PNC, we very well know, can take part in IGP and learn the topology. It can learn via BGP-LS. There has been other proposals like PSEP-LS, as well as Yang-based, the T topology model mechanism to learn the topology. But the topology between the PNC and MDSC and the domain controller and supercontroller would also need to worry about the abstraction. And this level of, and we have the other document which talks about various level of abstractions that could be there, which is white topology, gray topology, black topology. And all those things are already well supported with the protocols that we have. So for example, in BGP-LS case or PSEP-LS case, we could carry abstract topology and mark that this topology, how it is being abstracted. And of course, the Yang-T model captures this quite well. But the job of the MDSC is also to take care of the end-to-end topology that it might be exposing to the customer. So we have just tried to, at one place, try to list all the different possibilities that is there with respect to the topology building. So you have your the Yang-based work that we do in this working group, but then there is some other pointers to other things that are happening which are outside the working group as well. Similarly, with path computation and instantiation, completely aligned to the ACTN framework, what we have already captured. And again, it lists what are the possibilities for us to actually do this work. It could be Yang-based. There as well, we have two options. We have the T-tunnel compute only and other options, as well as to instantiate a tunnel via the T topology model. We have the path computation Yang model, which uses the RPCs. So these are the set of things which are Yang-based. And of course, via PSEP-based work that we have been doing in the PC working group, which is how stateful HPC could be used to do path setup from supercontroller or the MDSC to PNC. So nothing new here. This is just to list what are the possible options that we have when we are implementing this. Next, we move on to some of the services that we offer. So we are focusing here on the IP services. So seamless MPLS, L3 VPN, L2 VPN, etc. So what are the various interactions that needs to be done when we have to establish a service? So in case of a seamless MPLS, what are the jobs that the controller needs to do? What would be done via various interfaces? So that we have tried to capture that. One of the key things that the supercontroller might have to do is selection of what are the boundary nodes or the ABRs that I need to use. Of course, you need to do the service model to the network model to device model translation, which has been discussed in the ops area as well. And apart from the configuration part, there is of course the tunnel selection and the ACTN part that comes in, that what are the paths that needs to be set up, how do we set up per domain paths and stitch them together to form end-to-end LSP. So that part we have tried to capture. Another key thing would also be, is there any role of running control plane protocols like BGP between the domain controller and the supercontroller in form of RR functionality that the BGP provides, and what else, how we could use that information at the supercontroller to make some intelligent decisions, etc. Similarly, in L3 VPN, this is actually covered in the service model part as well, where we were talking about how the mapping between the service model and the ACTN and the T would be done. So this kind of captures that. And though sometimes we may receive the service in form of a service model, we need to decide based on the QoS and policy requirements what kind of tunnels that needs to be actually established, what are the set of boundary nodes that I have to use, and what is the map type. For example, this is something that was discussed in the service model. So that is captured here, that there might be a requirement to bind a tunnel or to reuse a tunnel or just make some modifications. So those things are captured. And what will be the mechanism used? So if we are using ACTN interfaces, we have a choice of what's the job of the the MPI interfaces, and it can be implemented via PCEP or it could be implemented via the YANG mechanism. But apart from that, we also have the configuration translation from a service model into the network model, into the device model. And something that we are highlighting is that the network model is some piece that is kind of missing. We have the service model, we have the device model, but representing this at the network domain level is something that needs to be worked on. And what's applicable to L3SM is also applicable to L2SM for giving L2 VPN or eVPN services. Then we move on to the protocols and the models. So those were the services. What are the choices with respect to various protocols? So we have some control plane protocols that could be used. So we have tried to capture PC and BGP, and possibly if there is a role of BMP there, that's something that needs to be investigated further. And with respect to management plane, what are the various sets of YANG model and what are the roles that those YANG models are playing? So PC has a long history that this is the ladder that the PC working group has worked on, and we are very well aligned to the requirements that we have with respect to this hierarchy of IP controllers. With respect to YANG models, the service models are well established. Something which we need to think about a little is the network configuration model, where from the domain point of view, how do we represent what is the service that needs to be implemented, which gets translated into the device model, which is the VRF and the actual instantiation on the border nodes. The work about topology and tunnel, that's well established. The VN and the service mapping is what we discussed and how we would do. Another thing we need to worry about is how do we give the status or the OEM functionality to while we are establishing these IP services, and how we link them with the service part as well as the network tunnel part, and how do we give a unified view to the customer. So that's something that's missing, and I'm sure there are other YANG models that are being developed at other places that we would like to capture, so that we can point out to how, if we have to implement this, these are the set of things that you need to look at. Some of the things that we are highlighting as a possible features or extensions that can be done, and it of course depends upon the protocol choice, and based on that protocol, how do you implement these things. The initial configuration right now, when we are establishing various controllers and you have a domain controller and a super controller or a PNC and MDSC, how is this relationship established? How do we learn about their individual capabilities and the role that they are playing? And how do we work with when you have multiple instances of the same controller at different level for reliability? How is your protocol taking that into consideration? So those are the things that we need to think about and highlight while we are also working on this topic. So the aim for this presentation was basically to get some feedback on whether this kind of work is useful, and what else are we not thinking about, what can be added, what's not in scope, and thus should be removed. We still, of course, agree that this is just the starting point. There is a lot of things which are missing. So some of the things that we know that we have not added is about YANG models, more details about BGP, OEM, etc. So if this is something that interests you, please help us and join us. And I'm done. Thank you.
Any comments? All right. Thank you very much. This ends our TEAS working group session in London. We do not have another session. We don't have a joint session. Thank you very much for contributing. Look forward to seeing contribution on the list. Oh, blue sheet. We're missing a blue sheet. Does someone have the other blue sheet? Guess not.